So in this question, a motor weighing 50 Newton is supported by a frame. It is hinged at one end, and a roller support is on the other end. Okay, if motor exerts, that's a motor down there. The motor exerts a moment of 5 Newton in the clockwise direction. We have to find the support reaction at that two hinged point. I mean, one is hinged and the other one is roller. We have to find the support reaction R1 and R2. So how to solve this problem? So first of all, uh, just take the momentum. Okay, we have a motor. So if I extend the force 50 Newton downwards, it will intersect at a point 0.2 meter from the right part or that roller part. They are already given the length as 0.2 meter. Okay, and remaining 0.6 meter. So suppose I am taking the moment about R2, that point, I mean hinged point. I can take at any point because it is in equilibrium, right? So for basic law of equilibrium means that the forces are in equilibrium and moment at any point will be zero. So first of all, I will be taking moment at any point will be zero. So I need to get R1 and R2. So I will be taking about R2, moment about R2 be zero, assuming. So since moment about R2 I am taking, I cannot take the force R2 because that distance will be zero. So only the forces which cause the moment about the point, the reaction R2, that or the hinged point is R1 and that 50 Newton downwards. So R1 into that whole distance to that point, I mean the hinged point is 0.8, 0.6 plus 0.2, 0.8. So R1 into 0.8, and it will be in the anti-clockwise direction. So I could write it in one side of the equation, and the other side I can write that 50 Newton because it will be clockwise direction with respect to that point, hinged point. So 15 into so that 15 Newton is in clockwise direction. I mean moment due to the 15 Newton is clockwise direction with respect to the hinge point. So 15 into 0.6 meter, right? So 0.6 meter is the distance from that hinged point to that x force direction of 15 Newton. So 15 into 0.6 plus 5. They already said there is a 5 Newton in the clockwise direction, right? So I can write that along with this positive momentum, I mean clockwise momentum due to 15 Newton. So on the other side it will be 15 into 0.6 plus at 5 Newton clockwise, because these both are in the same direction. That is why I write in the other side of the equation. On the other hand, the force due to, I mean moment due to R1 is anti-clockwise direction. That's why I write in the other direction. Okay, so I have to write the, I mean based on direction, I mean clockwise direction one direction and one side, and anti-clockwise the other side. Okay, so from that I get R1 by equating I R1. Then by simply applying the, I mean equilibrium force, right? Vertical direction not to be equilibrium. R1 is upward, R2 is downward, so R1 minus R2, and the only force downward is 15 Newton, right? So just apply the basic equilibrium law. I mean in vertical direction, this just based on the convention. So from that I can write R2. Okay, so we get both the values of R1 and R2. R1 is 17.5 Newton and R2 is 2.5 Newton.